Have you ever tried taking the square root of a negative number and your calculator gave up on you? Well, welcome to the world where the impossible becomes possible. Welcome to the land of complex numbers. Mathematics has always helped us understand the world, from counting stars to sending rockets to Mars. But then came a question that stumped the mathematicians for centuries. What is the square root of -1? For years, the answer was, you can't do that. But then, someone dared to imagine a new kind of numbers, one that doesn't lie on the usual number line. They call it I or iota, the imaginary unit, and with it, a whole new universe of numbers was born, the complex numbers. Complex numbers are an incredibly powerful and versatile tool, used across a wide range of fields. They allow us to represent and work with mathematical and physical quantities in ways that real numbers alone simply can't. Welcome to the comprehensive course in complex numbers. By the end of the session, you will learn about the historical background of the development of complex numbers and the contemporary scope in complex numbers. You would be able to define complex numbers and then to represent it in algebraic, geometric, and the polar forms. The fourth objective of this video is to master the operations such as addition, subtraction, multiplication, and division of complex numbers. And the last one is De Moivre's theorem. Of course, we are going to learn about the concepts related to complex numbers. Along with that, we are also going to do many questions and problems, quality questions. I recommend that you carry a pen and paper handy so that you will be able to solve questions and you will be able to jot down important concepts while watching the video. The journey of complex numbers began with a mystery. How do we take the square root of a negative number? This question puzzled mathematicians for centuries. In the 16th century, Cardano, an Italian mathematician, was one of the first to use square roots of negative numbers while solving cubic equations. Although he called them useless, he planted the seed for what would later grow into complex number theory. Later, Raphael Bombelli gave structure to these mysterious numbers. In the 1570s, he defined rules for manipulating square roots of negative numbers, helping make sense of what we now call imaginary numbers. But the very interesting term imaginary was introduced by René Descartes in the 17th century, though he meant it as a criticism. Ironically, these numbers would become incredibly important. In the 18th century, Leonhard Euler made a major contribution by introducing the symbol I for under root -1, which is called iota, and linking complex numbers to trigonometry and exponential functions through the famous Euler's formula. In the 19th century, Carl Friedrich Gauss gave complex numbers their modern geometric interpretation as point on a plane and proved they were essential in solving all polynomial equations, fundamental theorem of algebra. Today, complex numbers are used not only in mathematics, but in engineering, physics, signal processing, and quantum mechanics. What began as a curious imaginary idea became a very real tool for understanding the universe.